Alright, welcome to lesson 3.3 and 3.4. We're going to look at how to prove lines parallel, and we're also going to look at some properties of parallel and perpendicular lines, which is kind of a special case situation. So first we need to recap on transversals. Recall that if two lines are parallel, like L and M here are parallel, then a line is drawn across them, you get a whole bunch of corresponding congruent angles. So corresponding means they're in the same position. So if you look at the top and the bottom intersections, 1 and 5 are both in the top left quadrant there. So they are going to be congruent. Same with 2 and 6 are congruent, 3 and 7 are congruent, 4 and 8 are congruent. So that's something we already know about transversals, or when a line goes across parallel lines. You get all these pairs of corresponding congruent angles. Now, it's worth noting that there are more pairs of congruent angles because 6 and 8 here, they're vertical. They're across from each other at this intersection, so they're going to be congruent because they're vertical angles. Same with 5 and 7, 1 and 3, 2 and 4, which means that angle 4 will actually be congruent to angle 6, or angle 5 will be congruent to angle 3, and a few other ones there that I'll let you think about. Okay, so that's what we learned before about parallel lines. What can we learn that's new about parallel lines? Well, we can do the converse of the corresponding angles theorem, which means instead of saying if the lines are parallel, then the angles are congruent, we can also say the backwards version of that, which is if the angles are congruent, then the lines must be parallel. So here, if angle 2 is congruent to angle 6, then L is parallel to this symbol right here, means is parallel to M. And in this case, we're using the lowercase script letters to identify the lines. Usually we use 2 points on the line, but you can also use lowercase script letters to, I say like italic. When I say script, that means italic. So okay, little technical difficulties there. The battery on my headset just died, but I got it plugged in now, so should be good to go. Okay, so we're going to use this, right? We're going to use this converse of corresponding angles theorem to say if we know the angles are congruent, we can prove that the lines are congruent. Let me give you an example of that. So here we have a situation, and this is how our proof situations look, as you saw in the last lesson. Given angle 1 is congruent to angle 5, and here's my picture over here, I have to prove that line A is congruent to line B. These ones happen to have these arrows here because that's the picture I got it from, but pretend we don't know that they're parallel and we have to prove it. Well, what we would do is we would say, first of all, we would make our 2 columns, statements and reasons, And as usually, we'd start with the thing that is given. So angle 1 is congruent to angle 5. How do we know that? It was given. And now, we don't really have to do very much in this one because we're just getting started here. But we can say that line A is parallel to line B. And our reason for that is that corresponding angles are congruent. And of course, I always forget to do this, but you should number your statements and then number the corresponding reasons. Don't rely on like lining them up really good. Just put those numbers in there. So I've proven that line A is parallel to line B. In the next slide, you're going to look at this question, or maybe it's 2 slides from now. But the next thing you're going to do is this question where you have to decide which lines are parallel. And when it says justify your answer, that means make that 2-column proof. So given this picture, if you know that angle 1 is congruent to angle 2, then which lines, either LM or AB, I'll give you a spoiler here, L and A, they're not parallel. But L and M might be, or it might be that A and B are parallel. Which ones can you tell are parallel based on the fact that angle 1 is congruent to angle 2? Okay, so that's your given thing. Go ahead and give that one a shot. And then we'll learn some more stuff about proving lines parallel. Good luck.